Can you solve this math challenge? Here's the question. If 8 raised to x minus 2 raised to x all over 4 raised to x minus 2 raised to x equals 17, then our goal is to find the value of x. Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so our goal is to solve for the value of x that satisfies this equation 8 raised to the power of x minus 2 raised to the power of x all over 4 raised to x minus 2 raised to x equals 17. Alright, to answer this question, take note of this 8 raised to the power of x, or simply this 8. This 8 can be written as 2 raised to the power of 3. Now, what we're going to do is to make all bases must be the same. So, 4 can be written as 2 raised to the power of 2. Now, let's use this law of exponent. If we have b raised to the power of a raised to the power of c, this can be written as b raised to the power of c raised to the power of a. So, we can interchange their exponents. Therefore, 2 raised to 3 raised to the power of x can be written as 2 raised to x raised to the power of 3, and 2 raised to 2 raised to the power of x can be written as 2 raised to x raised to the power of 2, like this. Now, take note that we have a common term of 2 raised to the power of x. We have 4 of them. So what we're going to do is to replace this 2 raised to the power of x with a single variable, and let's use the variable y. So let y be equal to 2 raised to the power of x. Now, we can replace all 2 raised to the power of x with the variable y, like this. So now we have y cubed minus y all over y squared minus y equals 17. Now, on the numerator and the denominator, we can factor out a factor of y, like this. So the numerator becomes y multiplied by y squared minus 1, and the denominator becomes y multiplied by y minus 1. Alright. Now, as you can see, we can cancel out the variable y. The reason, because y equals to 2 raised to the power of x, and we know for sure that y must be greater than 0, because 2 raised to x is an exponential function. Now, we can now cancel out y because we know y is not equal to 0. Next, on the numerator, we have a square number minus another square number because 1 can be written as 1 squared. So now we can use the difference of 2 squares. So if we have a squared minus b squared, this can be factored as a minus b multiplied by a plus b. Therefore, the numerator can be factored as y minus 1 multiplied by y plus 1. Now, before we cancel y minus 1 on the numerator and the denominator, let's make an assumption that y is not equal to 1, because otherwise, when y equals to 1, then y minus 1 must be equal to 0, and we don't want to have that 1. Therefore, assume now that y is not equal to 1. Alright, so we can now cancel out y minus 1 on the numerator and the denominator. So this looks like y plus 1 equals 17. Now, we can now solve for the value of x because we know y must be equal to 2 raised to the power of x. So we can replace this y with 2 raised to the power of x. So we have 2 raised to x plus 1 equals 17. Now, let's subtract 1 on both sides and let's solve for the value of x. 17 minus 1 will give us 16. And take note, 16 can be written as 2 raised to the power of 4. So we can replace 16 as 2 raised to the 4th power. Now, we have an equal expression and we have equal bases. It follows that their exponent must be the same. Therefore, we can say that the value of x must be equal to 4. And that's the answer to this question. So, if 8 raised to x minus 2 raised to x over 4 raised to x minus 2 raised to x equals 17, then the value of x, the only real value of x, satisfies this equation is x equals 4. And as always, we are done.